Hello everyone. My name is Junia Hirano. Thank you for giving me this valuable opportunity. I will now begin explaining my solution. I am Japanese. I do not have any English skills. Therefore, I will use text-to-speech software for explanations. I apologize if there is any problem. First, I'll touch on my background. I am already retired. Previously, I was involved in work related to asset management. I am somewhat familiar with financial data processing. However, I have no professional experience with machine learning. After I retired, I taught myself programming using an introductory book. It's not for the purpose of work or income, but rather as a hobby. I have been participating in Kaggle for 2 years. I have only won one medal in the past. I won silver in a competition called ICR. It was a competition where there was a big change in rankings like this time. My rankings in other competitions have been around the middle. I'm old and an amateur. I cannot explain in the same way as professionals, but I will try from the next page. This page summarizes my solution. The first item is pre-processing. I don't use any unique method. As I will explain later, one of the models I used is transformer. Since it was necessary for the input, I performed normalization and null values imputation. For null values imputation, I used the mean grouped by age and sex. The second is the models. I used an ensemble of 3 models. The weights are equal. The models are Vision Transformer, Light GBM, and CatBoost. I changed the input layers code of the Vision Transformer. Last is learning. Metric and cross-validation are as you can see. Like many participants, I used a threshold rounder. From the next page, I will explain each item in detail. I'll start by explaining the pre-processing. First is CSV data. I used the number of null values in each row as a new feature. There are 91 features in total. Among them, the importance of this feature by Light GBM was 28th. I also calculated the mean and STD of each row for physical, FGC, and BIA. To match the scale, I normalized the data before calculation. The importance of these new features was relatively high. For example, the mean of physical was 7th, the STD was 11th, and the STD of FGC was 13th. Next is parquet data. I used data with a non-wear flag of 0.5 or less. As you can see, I used mean, STD, and skew to create one row of data for each ID. Among them, the one with the highest importance was the skew of ENMO. This was 21st, followed by the mean of X at 22nd. In addition, the STD of ANGLAs was 31st, and the skew of Y was 32nd. For relative date PCIAT, I used min and max. The importance of min was 30th. Next is categorical features. As you can see, I processed the seasonal data. However, this didn't work well. Many of the features were near the bottom of the importance list, and the highest was 42nd. I used all the categorical features except season as they were. It means I didn't try hard enough, and this is something I should reflect. Next is null values imputation. Many participants seem to have tried various techniques, but I chose a simple method using mean. Last is normalization. I applied the min and max of the training data to the test data as well. I would like to add that I did not use dimensionality reduction in pre-processing. Next is models. As explained in the summary, I used an ensemble of 3 models. The weights are equal. Of the 3 models, I changed the input layers code of the vision transformer. The changes are as you can see. I simply replaced the input layers for image processing. I don't understand how transformer can be used to solve classification and regression problems. The reason I applied vision transformer was because it was easy for me to use. In other competitions, I had the experience of getting roughly the same score as light GBM, so I tried it again this time. Next is learning. The metric is May. On the other hand, I set the loss for light GBM and cat boost to MSE. This difference is the result of considering the CV score. The same goes for the learning rate. I decided based on the CV score. I set the split for cross-validation to 5. The stratification method of stratified k-fold is SII. Since the scores for each fold were not stable, it may have been better to try other stratification methods. This point is also something to reflect on. The threshold rounder is as you can see. I used it in the last stage of prediction. This page is parameter details. I made adjustments based on values that gave good scores in other competitions. I did not use Optuna or grid search. In hindsight, I feel that not using them was one of the reasons for the gold medal. I did not use the GPU for light GBM and cat boost. I might be wrong, but the reason is that there are restrictions on parameter settings. Next is the learning result. Runtime is approximately 21 minutes. The long runtime was due to the 50 epochs of transformer and not using GPU for light GBM and cat boost. The scores are as you can see. Public LB was 0.471, private LB was 0.476. These scores are close to CV's 0.481, and I think they are generally in line with the learning results. Please see the table. These are the scores before processing with threshold rounder. The single model with the highest score was light GBM. There is almost no difference between transformer and cat boost. The CV of the highest light GBM is 0.393. Although not shown in the table, the simple average of CV is 0.385. Ensemble, on the other hand, is 0.408. You can see that the ensemble was effective. The scores per fold were not stable for either single models or the ensemble. The fluctuations in transformer were particularly noticeable. I also tried changing the random seed, but that didn't work. This page is about feature importance. I used the importance from LightGBM. Please see the table. The number of features is 91 in total. I converted the sum of importance to 1. Underscore R means after null values imputation. The top 4 features accounted for about 30% of the total. The top 15 features accounted for about 50%, the top 31 for about 70%, and the top 58 for about 90%. The features with relatively high importance were age and height, time spent on the internet, and SDS. It can be assumed that there is a high correlation between age and height. If height is excluded, it is assumed that age becomes even more important. Next is the effect of the solution change. The change that worked was using transformer. The upper table shows the before and after scores. Both public LB and private LB show improvements. Also, the difference between CV and leaderboard scores has become smaller. You can see that the change worked. The changes that did not work were optimizing ensemble weights, learning with kappa as the metric, and learning with PCIAT total as the target. The scores are as shown in the lower table. Of these, the change in metric had a good CV, but the leaderboard score did not improve as much as expected. Even for the changes that did not work, private LB was at a relatively high level. All of them are equivalent to a silver medal or higher on the final leaderboard. This would seem to indicate that my learning attempts did not fall into overfitting. I also tried other changes, such as removing low importance features, but they didn't work. This is the last page. I will touch on the surprises and lessons learned through this competition. The biggest surprise was the change in ranking. I think this is the same for everyone. I gave up trying to improve my score 2 months before the deadline. My rankings in other competitions have generally been around the middle. I assumed it would be the same this time. However, the result was an unbelievable 6th place. There was no unique technique in my solution. I could have imitated the published code by more skilled participants, but I did not do so. In hindsight, I think not imitating led to my result this time. I don't know if overfitting affected the ranking change. Still, I learned once again that the pursuit of a public score can sometimes lead to bad moves. This concludes my explanation. It may have been boring for professionals. I would be happy if I could help you understand the surprising changes in rankings, even if just a little. Thank you for your attention.